Good afternoon. Welcome to today's TASA webinar, Critical Issues in Bus and Light Rail Vehicle Passenger Safety. Passengers riding a bus or a light rail vehicle expect to travel from point A to point B safely. After boarding the vehicle, walking within its environment, and taking a seat, the passenger places his or her fate in the vehicle operator's hands, and it is a reasonable expectation that the transportation company will take due care of the passenger. This webinar will discuss and identify best practices for safe bus and light rail vehicle passenger operation. During today's program, the presenter will cover the following: access and stop design guidelines, waiting for the vehicle, boarding and disembarking the vehicle, passenger onboard safety, and security. The presenter for today's webinar is Dr. Carl Berkowitz. Dr. Berkowitz has 48 years of transportation and traffic engineering experience. He has served as a litigation consultant and held various positions in industry, government, and higher education, with extensive experience in planning, design, safety, security, construction, maintenance, operations, and management. He holds a BCE in civil engineering and an MBA in industrial management from the City College of New York, and an MS in transportation planning and a PhD in transportation planning and engineering from the Polytechnic University, NYU Poly. In addition to his work involving pedestrians and virtually every form of transportation and its safety, including aviation and maritime, Dr. Berkowitz has written numerous reports and articles for major publications, chaired task forces, appeared on national television and radio, and made numerous scholarly presentations worldwide. He holds memberships in many transportation professional associations. Dr. Berkowitz's areas of expertise include accident studies, slips, trips, and falls, pedestrian accidents, perception reaction capabilities, subway and commuter rail accidents, speed and distance analysis, and railroad grade crossing. Dr. Berkowitz would like to answer questions throughout the program. If you have a question, please use the chat or Q&A feature located on the right-hand side of the screen to submit your question to the presenter. We encourage all attendees to submit questions throughout the presentation. Tomorrow morning, I will send out an email with a link to the archived recording of this webinar, and we do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I'm now going to turn the program over to our distinguished presenter, Dr. Carl Berkowitz. Carl, the program is all yours.
Thank you very much, Matt. And it looks like we have a question before we even started, and I've read the question, and I could assure the questioner that we cover that subject in detail. So if the questioner will be patient, later on in the presentation we will be covering that subject. As you mentioned, basically the primary topics of the seminar are access and stop guidelines, waiting for the bus or the light rail, boarding and disembarking, and onboard safety. This is an axiom, maxim that we always see brought forward in any accident, that there's a tendency to blame the passenger who's involved in a bus or a light rail related accident or any transportation accident for not being careful or not watching where they are going, rather than addressing the issues that might be more critical than that. The bus and light rail providers, those agencies that provide service, play a very important role in making systems safe for passengers. They ensure that the vehicles operate safely near the passengers and that the passengers on board are taken care of in a safe manner. They ensure that stops and stations provide safe access for the passengers. And here are some examples of various bus and light rails operations around the United States and the country. When we're looking at accident prevention in terms of bus and light rail, the first level of accident prevention is quite a no-brainer. It's removing the hazardous condition in the first place. There are three basic types of light rail operations in the United States. The largest operations are light rail transit, and these are electric railway operations where there could be one car or more cars. It could be as many as 8 cars, 6 cars, 8 cars, and it operates on ground level or on an arterial structure in a subway, in a street situation, and passengers in this type of system are either are let off at the track level or at the car floor level. But the nice thing about the light rail transit that their floor where the passengers board is pretty low to the ground. The second type of system is the streetcar, which goes back many, many years, and these are the original electric-powered rail cars that operated in short trains and mixed traffic right on the streets. I remember growing up in New York City and riding these systems. A third type of system is what we call the trolley car, and what distinguishes the trolley car from the other systems is the method in which it receives its power. And in this case, it receives its power from an overhead wire, and the trolley has a wheel device on top that sits on the wire, and the power is received, the electrical power is received to operate the car. Light rail vehicles have a significant accident history. In 2000, there were approximately 1,300 different types of accidents, and we noticed that in 2009 that this level of accidents has gone down to 800 and approximately 30. And in fact, the fatalities have seen a similar decline from 34 to 26. Grace crossing fatalities have remained somewhat constant, and passenger injuries have also seen a significant decline. The nice thing about, as I mentioned before, the nice thing about the light rail vehicles is that the floor is located very close to the ground. So this makes it a very advantageous system for people traveling with young children, for the disabled persons, people with impaired vision. As you can see in the pictures here, wheelchair users have an easy time boarding these types of vehicles. If you have luggage or a shopping cart or some kind of something you're pushing along like a stroller, it's easy to board. And of course, for elderly people, it provides a no step-up type of linkage between the car and the platform. The light rail vehicles operate on 3 different basic types of right-of-way. That's one where they're similar to a regular railroad operation, where you have a ballasted track separated from other activities, completely separated. Then you have what we have is segregated tracks, which run in the center of roadways and street systems. And the third is right there in the traffic stream. And this is very common. We see those in various places in the United States, most particularly in San Francisco. Over the years, because of accidents that have occurred, the most modern vehicles are designed to better protect the passengers through stronger construction that prevents injuries from passengers or protects passengers from injuries that might result in the event of a collision between the vehicle, the light rail vehicle, and another vehicle. Many of these systems operate in the United States, and there's approximately 35 of them. A lot of them have closed-circuit television to monitor door closings and rear road traffic activities. And some of the light rail vehicles have as many as 6 cameras observing the activities in the vehicle and outside the vehicle. A lot of the systems also have a priority control where the operator of the vehicle, when approaching an intersection, has the ability of changing the signal in favor of the light rail vehicle. In addition to that, there are a lot of technologies that have been added to the vehicle, such as electric displays in stations and vehicles, which give you next station, arriving times, time between stations, delays, the route maps, things of that nature. This is just a chart that shows the 3 basic types of light rail vehicles, the 2 types of light rail vehicles, and comparing it with subway cars. And in general, they run 1 to 4 vehicles, but they can run longer than that. And the trams or the streetcars are basically a one vehicle, and in some places you can see them operating as two vehicles, as compared to subway trains, which run from 4 to 10 vehicles. And also the length and the number of passengers carried in a light rail vehicle is significantly more than a rapid transit system vehicle. This is just a montage of some of the different kinds of light rail vehicles and streetcars and trams that are operating both in the United States and abroad. There's some additional ones. Down in the bottom you see some of the old traditional trolley cars. Now on the bus side, we have basically in service carrying passengers 6 different types of buses. We have the minibus, which is a small bus carrying maybe 12 passengers, the mid-sized bus, which can carry maybe 20 or so passengers, and the standard city bus, which carries somewhere around 40 or 50 passengers, the suburban bus, which carries about a similar amount. These are seated passengers. And then the double-decker bus, and becoming more and more popular is the articulated bus, which is 2 buses with 2 units together to form one bus. There's also, in many places, we are finding on streets that there are bus-only lanes. There are also segregated bus lanes, and in some places they even have something that looks like a track. That's in the lower right-hand corner. The bus operates on its own track. And in the upper left, we see some of the signage that indicates the relationship of the busway to the intersection. In terms of bus accidents, there are significantly more bus accidents than there are in light rail vehicles, because buses carry a great deal more passengers. As I mentioned earlier, there are about 35 systems in the United States, with another 70 planned. And in terms of bus systems, there are thousands in the United States. Every community, small to large, has some sort of passenger operation, bus passenger operation. One thing that's to be noted is half of the fatalities are the result of rollovers, and 70% of those accidents are from people who are ejected from the buses. And motor coach accidents have received a lot of publicity recently. And one of the issues that has been raised by Hutchinson-Brown legislation is that there is a need for legislation so that motor coaches, these are primarily the intercity or intra-city express bus type of operations, that they do not have to meet the same standards as cars and airplanes in terms of seat belts and other safety conditions. So legislation is being introduced. It's being referred to as the Motor Coach Enhancement Safety Act of 2011, and they hope that this will pass. It has not yet, but that sometime in the near future will pass. In terms of fatalities on buses, we've seen an increase in recent years, and the number of persons injured has remained kind of constant, as well as the number of vehicles involved. And we've seen some kind of, in case of bus operations, there has also been some kind of growth in this area as well. So this can also attribute to the increase or the consistency of the accident history. There are a lot of legal considerations. In recent years, the courts have ruled that transit agencies are obliged to address the safety of passengers, not only on the vehicle, but assessing their systems, leaving their systems, and in fact even transferring from one system to another. Some of the legal context for these requirements are, for example, the Uniform Vehicle Codes and the American with Disabilities Act set out standards for access and ride and occupancy safety. And it's been held that transit agencies bear some of the responsibility ensuring that passengers can access stops and stations safely, and even if the property that the stop is on or the station is on does not belong to the agency. Some of the common safety issues that are addressed and are of concern is that the vehicle operator sometimes cannot confirm when it's a light rail system that the gates and the light systems are working. There is no feedback that the vehicle operator currently receives. Sometimes the person who crosses or the vehicle that crosses a light rail system is confused about the moving light rail. In some cases, the light rail also shares the right-of-way with other moving trains, and the person crossing or the vehicle crossing is not really able to differentiate between a slow-moving train and maybe a faster-moving light rail vehicle. In some cases, there are sight distance limitations at the crossing, not giving clear image as to how far away the light rail vehicle is. And other things of concern are the automatic gates and traffic signal interconnecting failures, and pedestrians being confused when both there's a signal light and a light rail light at the same intersection. And sometimes there's confusion when you have trains moving in both directions. All of a sudden the gate goes down, it goes up, and comes down again. Some of the common safety problems that pedestrians face on a daily basis include crossings that have limited warning, darting across the tracks without looking, ignoring signs, trespassing on the right-of-way, and they don't cross at designated areas, and in some cases the gate has come down behind the pedestrian and they're not sure what to do. One thing of serious concern, and this sort of highlights that, is the effect of speed on safety. And you could see that the faster a vehicle is traveling, the less ability that vehicle has to stop. And that has to be kept in mind when crossing the right-of-way, whether it's a bus or a light rail, that there's a thinking time and a braking time, and in combination is a stopping time. And this graph points out how much time and distance is required to stop at different speeds. The operator's view, and the faster the operator goes, the smaller is their view as to what's happening out there. And you can see at 50 miles an hour, and that child on a bicycle, the operator has a very good view. When it comes to going 40 miles an hour, that view is almost instantaneous. And there's little room for error on the part of the operator. We experience a lot of bad behavior out there, and these are some of the examples of bad behavior. Texting, playing with the GPS, eating, putting on lipstick, entering and trespassing on the right-of-way. The Federal Motor Carrier Safety Administration just published a regulation which prohibits texting while driving a commercial vehicle. This has not yet been extended to other than interstate or interstate-related services, and eventually I'm sure this will be extended to all modes of motor vehicle and rail transportation. And you can see how much more time it takes when you're texting when you have the car under control. You need another 30 feet just to stop that vehicle. Some of the pedestrian interactions. Pedestrians are less restricted than vehicles, and they can move pretty much freely when there's a bus or a light rail vehicle in front of them, and they can react much more quickly. And they are usually very successful in avoiding being struck by either those type of vehicles because of their ability to be able to take actions when having knowledge on an instantaneous basis. Some of the dangerous pedestrian behaviors that have been identified are where they cross the right-of-ways on an informal pathway, where there are no facilities for a safe crossing, where they run across the roadway to catch either a bus or a light rail, walking between stopped or parked vehicles, and even running between stopped and parked vehicles, stepping in front of traffic to get around an obstacle. Their perception of risk and how that is enforced is an issue, and the average person's speed and pace of life creates a behavior problem. And it's very difficult in most cases for the pedestrian to judge the speed of a vehicle crossing, crossing in front of them. And a lot of pedestrians are unaware of the laws which they're responsible to follow, and there's generally a herd mentality, and you see a lot of that in big cities where people do things illegally and everybody follows right behind. There are dangers in the general environment, and that is lack of crossing devices. People tend to form these informal crossings because there is lack of convenient crossings like mid-block. Sometimes the roadways are so wide that it's difficult to cross. Signals are sometimes poorly timed and do not allow the pedestrian to successfully cross. There are poor walkways and sometimes absence of walkways. Sometimes the walkways don't have capacity. In New York City, they have a concerted effort right now to make improvements and to provide mid-crossing safety areas, improve the timings, improve the radiuses of curvatures to make it easier for pedestrians to cross. In fact, the City of New York has published a interesting design handbook that covers that. In terms of national standards for crossings, the three areas are the American Public Transit Association, the Federal Highway Administration, which has a highway grade crossing handbook, and the U.S. Department of Transportation, in concert with the American Association of State Highway and Transportation Officials, which represents all the states in the United States, have developed a manual for uniform traffic control devices. When approaching the crossing, it's important that the person approaching the crossing recognizes that there is a crossing ahead and that they can begin to search for a train or a signal, and they can decide on the proper course of action and able to make the proper decisions. And they need information in order to make those proper decisions. And one of the things that helps in this case is when they're familiar with the pathway. And especially this is important for disabled persons because they like consistency. They like to know every time they come to a crosswalk that the crossing is similar to the previous experiences that they've had. Matt, if there's any questions at this time?
We do have a couple questions in the queue, and if those in the audience have a question, please use the chat feature or Q&A feature to submit them. Carl, what's the key to determining jurisdictional responsibility at a pedestrian crossing?
Well, in terms of a railroad crossing or a light rail crossing, it's mostly in railroad crossings there is different jurisdiction responsibility. The railroad has responsibility in the railroad crossing, and to a certain number of feet away from the railroad crossing, it becomes a local jurisdiction. In the case of the other services, since they operate primarily in the right-of-way, the local transportation authority or local government jurisdiction generally has the responsibility for taking care of that crossing. Could be a municipality, a county, or a state government.
Okay, excellent. And here's another question. Are transit systems subject to federal preemption? Currently, they are sort of self-governed in a sense. Light rail and bus operations do not have the regulations that the railroads have under the Federal Railroad Administration. There is Senator McCaskill in Maryland has introduced is in the process of introducing legislation where the requirements that the railroads have will be applied to light rail and bus operations. Currently, those types of rules don't apply, and there's a lot of self-government that exists in light rail and bus operations. Okay, great, Carl. We have one other question here from David, who asks, what guidelines govern a bus driver's duty to make sure all boarding passengers are secure before leaving a bus stop?
That's a good question, which we're going to be dealing with later on. But to give the short answer, it's the skills of the driver. These rules are not quite spelled out. there's usually rules and regulations of that authority which spell out the duties and responsibilities of that operator. There are not at this time any federal regulations. There are industry guidelines. The American Public Transit Association and others have guidelines for how a vehicle should be operated, and we'll talk about that in the next section. Does that answer that?
Yes, please continue on with the presentation of content.
Thank you. We have various types of intersections. We have controlled intersections and uncontrolled intersections. In the past, the uncontrolled intersections had various types of markings. They called them zebra stripes and other types of names. And in recent years, traffic engineers have been systematically removing these markings to a more basic type of crossing, uncontrolled crossing. For safe pedestrian crossing, whether it be for a bus or light rail, it's important that the crossing give the crosser an awareness of where the crossing is. There's clarity of the crossing. It's easily visible. It's a continuous path, and they're provided at appropriate intervals so that there isn't that desire to make mid-block crossings, that there's a short wait to make the crossing. The physical treatments are excellent. The pedestrian or passenger should feel secure. It provides accessibility for all types of individuals, even including people with disabilities. The surfaces are durable. The surface is compatible with other surfaces in the area, and there's a smoothness and width and surface that's acceptable for a good walking experience. There are various types of pedestrians, and they have various different needs and responsibilities. Child pedestrians, they have a little bit more difficulty than an adult to determine where to cross, and they are, because of their stature and their peripheral vision, they sometimes have difficulty in seeing and being seen, and they have a lot of, because of their inexperience, have a lot of difficulty in judging speed, and they need more time to cross, and that has to be taken into consideration in designing a crossing. A lot of the same things that affect young people also affect older pedestrians. Older pedestrians have reduced skills, and it makes it more difficult for them to maintain a brisk walking speed, and they sometimes have difficulty to turn their head, and they need more time as well to make the crossing, and they have the same difficulties as does young people. People with disabilities, similarly, and they also are affected by the surface area, and they need more time to cross, and they will benefit from information provided in multiple formats. And the formats that are generally used are audible, tactile, and visual. And like the other two groups, they also have trouble being seen and being seen by drivers. And there are special needs and requirements when you have a blind or low vision pedestrian who may have trouble detecting a vehicle or crossing. Another group which we sometimes don't take into consideration, and those are the recent immigrants who have difficulty with the language and difficulty understanding traffic signals, and they may come from areas where these types of traffic control devices are not familiar in the countries that they came from. And they have limited experience interacting, of course, with the vehicle operators. Some of the guidelines for transit crossings is having a proper turning radius, proper channels to minimize random crossings, refuge areas between when you have wide crossing areas, special considerations when you have an unsignalized, such as gates and barriers, maximal visual impact on the crossing so that people know exactly what's happening. And when you have on-street operations, the loading and unloading from the sidewalk should be at some raised medium platform and not the roadway itself. It's not a safe thing to have crossings at the roadway. And when there is a platform where trains come into and there's motion, there should be at least a 30-inch clearance away from the edge of the platform for safety of the passengers. Some of the signals that are used in light rail operations are shown here. This is a look both ways type of thing, and also a blinking light, and also some kind of horn or on noise that is sounded as well to alert that a vehicle is coming. Also, crossing gates are used at light rail crossings, reminding again to watch both ways, and also gates that come down in front of the sidewalk. Here's some examples of crossings that are in existence in the United States, and one of the things that we need to take into consideration is the sight distance that the pedestrian is able to see that the vehicle is coming and take appropriate action. And that's in a crossing where there may not be a gate or a flashing light or a horn sounding or a bell. Some of the improvements that can be made to make a crossing safer include various types of gates, including 4 quadrants where there's a gate in each of the 4 quadrants of the intersection. It's important to where the gate is also placed to ensure that people stay stopped in a position where they do not enter the dangerous right-of-way, and that there are warning devices that also provide warning to pedestrians that a vehicle is coming into the crossing. There are various traffic control devices that are used. There are what we call the active devices and the passive devices. Some of the active devices are listed here, from warning bells to pedestrian gates. And then we have a lot of passive devices such as tactile warning strips, railroad crossing signs, 2-track signs, do not stop on track signs, student crossings, and things of that nature. Despite all the injuries that occur, we still find young people still like to walk on tracks. This is sort of popularized in magazines and elsewhere, and children are found to use it because it sometimes provides the easiest way of going from point A to point B. It serves as a necessity for them. Because these vehicles are operating infrequently, they have a full sense of safety and comfort and security. There are, in some cases, a lack of physical barriers makes it very easy to access the right-of-way, the connectivity and the convenience, and the ability to, as I mentioned, to go from one destination to another. It plays a very big factor. In some communities, there's a lack of a street network, and the only link between community A and community B is the right-of-way. Some communities have lack of sidewalks, and there are topographical barriers like streams and roadways that prevent going from one point to the other and make the right-of-way very attractive. And, of course, your friends say, I do it, why aren't you? This peer pressure also encourages usage. One way to make right-of-way safe for youngsters is we need clarity of the right-of-way. There's got to be visibility. We need to, in cases where there could be an ongoing danger, eliminate access, provide the young people with alternate pathways between point A and B. The way we physically treat the right-of-way, security, compatibility with the environment, fencing, detectable warning, alternate path marking, signage, and passive and active control. And something that is being tested in recent years is intrusion control, where if somebody enters the right-of-way, the vehicle operator will have information about that intrusion into the right-of-way. These are some of the signages that you find out there on the right-of-ways, and there are some examples of fencing around right-of-ways. This intrusion detection looks like an opportunity in the future to protect crossings and right-of-ways. These systems are not expensive, and they're being tested around in various properties around the United States and internationally. And the intrusions detected along the right-of-way of any entry into the system. The design of the transit stop is very important in the design and operation of a system. The things to take into consideration are that the location of where the transit vehicle stops, whether it's a light rail or a bus, is that it's located in a safe place to protect the rider and also to encourage the use of the system. In locating a transit stop, either light rail or bus, everything that we're going to discuss applies basically to both. The operator and the passengers should be visible to each other. There should be adequate pathway width to the stop. It should be away from any obstruction so there's a clear view so that everyone can view each other. It should be close to pedestrian crossings. There should be space for a shelter on the stop so that in inclement weather there is some kind of protection for the passenger. It should be located so that walking distance is minimized, especially between transfer stops. You don't want a person getting off one vehicle and having to travel a significant distance to transfer to another vehicle. You want it to be close to an intersection, whether it's on the near side or the far side of the intersection, and should be designed so it does not interfere with the operation. And generally, that's why, in general, far side intersections are chosen to avoid interfering with the intersection operation. We also want to look at the environment that the stop is located in. Is it convenient and does it provide connectivity? Are the vehicle paths and heights of curb not too high and adequate to provide for a safe operation? That the waiting area has minimum street furniture not to interfere with its operation. That if required, there's information and ticketing machines. There is seating in the shelter. There are markings on the surface. There is some kind of posting of the routes that we'll be using the stop. There should be security, especially lighting. And there should be, but not in interfering with the shelter, in its vicinity, there should be a place for trash. In most cases, everybody has cell phones, but in some cases, there might be an area where the cell phone penetration isn't 100%, and you might want to provide phone, vendor boxes for newspapers, and also more and more systems are providing parking for bicycles so that it could be an intermodal trip, bicycle, pedestrian, and light rail or bus. In terms of laying out the stop, it should be unobstructed access to the stop. It should minimize the time spent at the stop by the vehicle. It should be very convenient, not only for the passenger but also for the vehicle. It should be designed so that the parking is for the vehicle is separate, and that their parking is for vehicles is not in the stop area, and that the bus should be able to line up within 2 inches of the curb and parallel to the curb. And we should be able to minimize the use of the curb space when there is competing demand for that space. And street furniture should be in such a place that it doesn't prevent passenger boarding and exiting the vehicle. Some places that transit stops are not appropriate, where there's a lot of pedestrian crossing activity, and where there's a lot of activity on the other side of the street, like shopping areas and things of that nature. These would not be suitable stops, where there's high traffic volume to cross, and where traffic speeds are high and multi-lane roads, and where there's an inability for a pedestrian to cross the traffic stream, and of course sight distance. This is, you can come back and look at this at another time. This is kind of detailed. This is the basic layout of meeting the ADA standards for the typical bus shelter and bus stop area. Here's some examples of accessible bus stops, and also an example of one that has a great deal of clutter. Here's some pictures of additional bus stops. This is an interesting bus stop. This is in Brazil, in Curitiba, which is considered to be one of the first environmental cities. Cities in the United States have tested these bus stops, but to my knowledge, none have implemented them. And this is where you have a raised bus stop, which enables the bus passenger to board directly into the bus without having to climb any stairs. And contained in the tube are also ticket machines, so you can buy your tickets and pay for your ride and and perform the transaction in the bus stop and not have to do any of the transaction on the bus. So all the bus activities, such as paying and that nature and boarding, are all taken care of in this bus tube. There are acceleration and deceleration standards, and it's interesting to note that they date back from the 1930s, and there's been little change since then. And basically, the acceleration and deceleration standard has remained almost uniformly standard in the United States at 1.3 meters per second square, or 4.3 feet per second square. In terms of acceleration and passenger comfort, this relates back to the question that was asked about sudden movement of a vehicle. These are the minimum, these are the maximum, actually. These are the standards to have passenger comfort and passenger safety. And you can see that there is the topic of jerk control, and that's when you're accelerating the vehicle, the acceleration should be at a normal, steady rate. And if there's a jump in the acceleration rate, we call that the jerk rate, and that's where you have a sudden jerking forward or a sudden jerking either on accelerating, or this could happen either when the vehicle is accelerating, and the same thing could happen when the vehicle is decelerating. Important to keep in mind is the elements of perception and reaction, that there's various steps that take place between a pedestrian being seen and an action being taken by a vehicle operator. And this process generally takes approximately 1 second, and these are the basic steps that the vehicle operator takes place in terms of the perception reaction of the vehicle operator of a pedestrian. Having an efficient perception reaction time doesn't necessarily guarantee that there won't be a tragedy. Everything has to go right, and anything that doesn't go right will add to the perception reaction time, and the result can be a serious accident. Reaction time is basically how fast one can react, and we all know from school that basic test where the teacher holds the ruler between our fingers and lets go of the ruler and sees how quickly we can grab the ruler before it touches the ground. That's a very simplistic view. In the case of a vehicle operator, it's being able to perceive something and then to be able to react to that perception. Any questions so far?
We do. We have a question from Cheryl, who asks, what is the duty of a driver on a light rail system to make sure no one is on the track when approaching a station?
The duty is that the operator should never, the vehicle should be operate within the speed limit which is posted, and should be always vigilant in terms of keeping out, because there's always a possibility of some unexpected experience happening. And in most cases, it's interesting that where people are found to be on the right-of-way, it's usually in the same location time in and time again. So operators should be informed by other operators when they learn of people intruding on the right-of-way, and at all times the operator should be vigilant, especially when visibility is limited.
Okay, great. Carl, do you want to tackle the, hold on, we have a question here from Jason, who asks, are there any laws requiring bus transit districts to maintain bus stops where they do not own the property?
I'm not sure about that. I know there are bus stops by agreement with the local property. We see them in Washington, D.C., on National Institute of Health property, when you go into the Pentagon. By invitation, we see bus stops that are located on private property. In shopping malls, it's by invitation, to my knowledge and experience.
Okay, we have another question here from David, who asks, how is evidence of sudden acceleration and jerk movements obtained?
Only if there is a black box that might be detectable on the black box information which will show acceleration rates and things of that nature. Basically, the best way is an individual experiencing it and others witnessing it.
Okay, great. Now, Carl, would you like to handle the question from Michael that was in the Q&A?
I will. I have a little bit more information on jerk, which I
okay.
would like.
Well, let's proceed with the third part of the presentation then.
Okay, and then when I get to that point, I'll address this.
Excellent.
These are some of the responsibilities. Somebody asked what are some of the responsibilities of an operator. An operator, these are not ingrained in the law, but these are things that are common sense and are basically expected of any vehicle operator. That they're focused, they're observing the right-of-way, they're prepared for an unexpected event. Whatever they do is predictable and lawful. That they don't work hours more than they should work, and they shouldn't be anticipating that they're end of their workday and they can't wait to get home to their family. Their attention should be clearly focused. Of course, operator expertise is very important. And when there is an incident that occurs, memories, I always think of the movie Rashomon, the Japanese movie, when asked about a stagecoach holdup, three witnesses gave 3 different accounts of the experience. There's no record better than a recorded record. Human errors on the part of anybody, vehicle operator or the passenger or pedestrian, has to do with attention, perception, knowledge, violation of rules, procedure errors, slips, lapses, and fatigues. Most accidents are usually a violation of some rule or regulation or some standard or guideline. They don't just occur by divine intervention. Some of the human fact issues in terms of vehicle operator, fatigue, inattention, lack of training. Considering the responsibilities, you would assume that all systems will provide the highest and best training to ensure that human errors are minimized, but this is not always the case. Some of the things that cause pedestrian accidents are distractions in attention, sight distance, inability to see the vehicle coming, awareness of the crossing, and lack of understanding of the potential hazard. There's been a lot of research done on attention, and this is very important that everyone has to pay close attention, both the vehicle operator and also the passenger pedestrian. On the case of the operator, they have multiple functions that they're doing, and they have a lot of responsibilities that they have to deal with, and they have to learn how to allocate the resources so they can accomplish all these things. And they have to know what to do when an unexpected event occurs. It's the operator's job to interpret information and to be able to deal with information. And if something interferes with that, the reaction time increases. And we know what happens when the reaction time and the time to stop increases. Bad things can happen. The distance it takes to make an emergency stop is really includes the perception time and the time for the vehicle to react and come to a full stop. And that's the applying of the emergency brakes, or if it's not an emergency stop, the applying of the normal brakes, standard brakes. There are lots of studies that have been done on vehicle operating human factors and perception and reaction times, and based upon the environment and the antecedents that might interfere, perception reaction time can run from 1 second to 4 seconds. The literature suggests that between 1 and 1.5 seconds is more than enough time to react to any unforeseen circumstance. And to be kept in mind in responding to pedestrian walking, that a pedestrian walks at 3 to 4 feet per second, and if a pedestrian is given 1 second of warning, because the pedestrian, except for wheelchaired and maybe visually impaired pedestrians, if the pedestrian is given enough warning, considering the right-of-way is the trackage is about 8 feet wide, if they're given a second warning, the chances are that they can get out of the way. And if they're given a slightly more warning than that, they definitely will be able to get out of the way of the oncoming vehicle. The emergency braking is approximately 3 meters per second square, which is approximately 10 feet per second square. And if there's severe braking, of course, what happens is that we exceed the jerk rate, and standing and sitting passengers can be endangered. And emergency braking should only be used when there is an emergency. One of the things that's very interesting is that when operators are queried, inquiries are made about their accident experience, they said the instant they saw the person in their way, they applied the emergency brakes. And we know from the previous discussion that there is a time that it takes, a perception time, for the brain to determine what's happening out there before action is taken. And there's a lot of technology that is being researched to try to provide help to the train operator or the vehicle operator. And in the lower right-hand corner, you see some of the technology in terms of accident avoidance technology that is being studied right now. One thing to keep in mind is that individuals have an inability to judge the arrival of an oncoming vehicle, and we have a difficult time. It's sort of like when we see an airplane overhead, it looks like it's not moving at all. And when we see light rail vehicles and even buses off in the distance, we tend to misjudge large objects in terms of what speed they are traveling at. A gentleman named Leibowitz hypothesized back in 1985 that about this concept that the vision underestimates the speed of large objects, and this has been confirmed in recent studies. Leibowitz hypothesized without doing a single study, and he, like Einstein in his theories, Leibowitz in his theory was confirmed by research today. Just take in mind that if you're traveling 10 miles an hour, you go 15 feet in 1 second, and in 3.4 seconds you go 50 feet. So just multiply that by 20 miles an hour, 30, 40, 50, 60, 70 miles an hour, and you can see the distance traveled. Not only do the vehicle operators have responsibility, but the pedestrians have responsibilities to obey the laws and the warning devices. And in order for them to have this responsibility, it's incumbent upon government and the operators to provide the right information so that the pedestrian can make the right decision. Here's some examples of pedestrian control systems across light rail vehicle crossings where they are channelized, and in fact even gates, automated gates are put in the way of the pedestrian so they cannot cross. There's a lot of signage that is used. This is particular to light rail vehicles, and one of the important things is to look in both directions, because you may look in one direction and lo and behold a vehicle comes in the other. A lot of systems are now going to photo enforcement to try to prevent bad behavior at crossings or on the right-of-ways, and they're using the same photographic technology that's being used now for red light crossings and for speeding. These are some examples of motion detector systems that are being tested on railroad right-of-ways to give the vehicle operator advance warning that there is somebody intruding on the right-of-way, and the Fuji Group in Japan has been doing a lot of work in this area. When there's an accident, there is two phases. There's the initial collision, and then there's the secondary collision, which impacts the passenger inside the vehicle, and this is where most of the injuries occur because of the biomechanical response of the individual to the vehicle crash. Excuse me. In terms of onboard safety, passengers are very vulnerable when they're standing or walking to their seat or just standing on the vehicle because there aren't sufficient number of seats. The use of the controls on the part of the vehicle operator can cause injury. A few seconds delay to allow passengers to be seated will make little difference in the trip, but will make a big difference in terms of the safety of the passengers. And a lot of passengers have reported back that they've experienced heavy braking and harsh acceleration on the part of the vehicle operator, and this is what we call the jerk. And also, in addition to the jerking of the vehicle, changing gears and steering too quickly can also throw, because of centrifugal force, can also cause passengers falls. The next few slides I'm not going to really discuss, but this is basically was developed by a group of bus drivers as how a bus should come into a bus stop and operate boarding and alighting passengers. And at your leisure, you could take a look at this. And this is what bus drivers suggesting to other bus drivers as the best way to operate the bus at a bus stop. These are some of the primary causes of occupant injuries. Some of them I've already mentioned, but are worth repeating. Passenger standing, sudden acceleration, crashing with another vehicle or pedestrian, the actions of the driver, the emergency braking, passenger being thrown against a component, and so on and so forth. These are those kinds of things. And basically, in-vehicle falls are generally caused by unsafe operation by the driver, but they could also be caused by the conditions of the floor of the bus. It could be slippery or something of that nature. Same things that occur in slip, trips, and falls. An uneven surface of the wearing surface, the walking surface, because it's not being maintained, and of course the swaying of the vehicle while moving. To begin answering Mr. Jacobs' question, these are the standards that have been adopted in terms of jerk rate. And so if one exceeds these rates of acceleration, there's a possibility of a passenger being injured, both a seated passenger, but more particularly a standing passenger being injured. A seated passenger might be moved off the seat, depending on their position, whether they're facing the direction the vehicle is moving or away, and whether it's a deceleration or an acceleration. Just to give you somewhat of an understanding, what we want to have is a very smooth acceleration rate. And graph 1, we see a smooth acceleration rate. If we don't have this smooth acceleration rate and we have these acceleration jerks, we have what we call the jerk rate, and we have the situation where somebody will fall in the vehicle, or even in some cases fall out of their seat. Another important issue is wheelchair safety and the importance of the wheelchair participant, the passenger, being properly taken care of and properly affixed or restrained on the vehicle. There are a lot of passenger information needs so that the passenger can travel safely, and these are some of the information that need to be provided to the passenger so they can make safe decisions. These are some of the warning signs that are used for light rail vehicle crossings. Those are the warning signs, and these are the regulation signs. And the most important, I guess, deterrent from preventing injuries is education enforcement, and waiting for the vehicle, identifying the correct vehicle, boarding the vehicle properly, understanding the vehicle, cannot stop fast, crossing the right place, and being aware of a hazard. There is a national campaign, and it is what happens if you hit it 30, and what happens if you hit it 40, and if you're a vehicle and you slow down, the difference in the injury is the difference between life and death. I'm sorry, we somehow got in the wrong. There's a program, Operation LifeSaver, to educate, enforce, and provide engineering advice to make crossing safe. And of course, at the end of the day, passengers need to be warned of hazards, personnel need to be properly trained, there need to be constant safety inspections, and standards need to be updated, and effective communication needs to be provided. And don't forget safety, safety, safety. For your information, I've just written 2 articles on platform safety. One is in the National Trial Lawyers magazine, and it's called Hazards of Railroad Platform, and it focuses on overcrowding. And Railway Terminal magazine, a magazine in England, there's an article on, even though it's titled Mind the Gap, it has to deal with railway accident, platform accidents. In England, any kind of railway activity, unsafe condition is usually put under the topic Mind the Gap. These are some previous web seminars that you will find on TASA's website. You might want to take a look at them. And in the future, we're planning 3 new seminars, one in passenger safety involving ferries and cruise ships. And it's absolutely amazing how many accidents occur on cruise ships and on ferries. There are many, many ferry operations in the United States and hundreds of cruise ships that operate out of the United States. And the other 2 are designing for pedestrian safety and school bus passenger safety. Thank you very much.
Thank you, Carl. What a great presentation. I think it shows that you put a lot of time and effort into it, and not only that, you know these topics very well. We have a couple final questions from those in attendance. We have a question here from Cheryl who asks, say a passenger has fallen on the track of a rapid rail system. What is the sight distance from the inside of a train where the driver is located to the train tracks where the passenger is disabled? What are some of the reasons the driver does not see the person on the tracks and the train collides with the passenger?
That's about a dozen questions.
Sorry about that.
Right. It's not a simple. It depends on the speed of the rapid transit vehicle. It depends on the lighting conditions. It depends on the track alignment. It depends on the activity, the curvature of the platform, and the visibility that the operator has ahead. It depends on when the person falls to the track. Did the person fall to the track right in front of the train, or was there a time lag? There are many variables that come into play. If the young lady wants to get in touch with me, I'd be happy to discuss it in more detail with her. But it's not as simple.
Yeah, I just sent her a message asking if Cheryl, if you're out there, if you want to discuss this further with Dr. Berkowitz offline, please just send me a message. Okay, I do not see any other questions in the queue, so I'm going to wrap things up here. First of all, I'd like to again thank Dr. Berkowitz for his time and effort with this presentation. I think we're all in agreement that it was very thorough and impressive, and he definitely knows these topics very well. If you'd like to speak to Carl Berkowitz about a case or project that you're working on, you can contact us here at TASA. Our telephone number is 800-523-2319. We will be sending out a link to the archived recording of this webinar tomorrow morning. I'll include in that email a link to the PowerPoint presentation so you'll have it for your records. The archived recording will also be posted in the Knowledge Center on TASA's website. As Carl mentioned in his concluding remarks, you are able to see all the previous TASA webinars in our Knowledge Center. They are archived, and we convert them over to video so you can watch them from the comfort of your office or home. If you have any follow-up questions or comments for Dr. Berkowitz or for me about the webinar series, we're always looking for ways to improve. Please email me at mhyde@tasanet.com. You will be getting a auto-generated email from me at 3:30 p.m. thanking you for attending. If you have any follow-up questions or comments, you can just simply respond to that email, and I will respond accordingly. We do hope to see you at future TASA events. We've got some great webinars coming up here at the end of June and throughout July, and we do hope that you have time to spend with us in the future. Thank you again, and I'm now going to end the meeting. Thank you.